In this video, we're going to look at finding an estimate for the mean, the median and the quartiles from continuous group data. Here I've got a table and I could use this to display continuous group data. So let's say I got a load of seeds, put them in a pot and I wanted plants to grow from them. We might be interested in the height of those plants after 5 days. So we could write in here now height, and we'd have this in millimeters, for example, and this would be the height of the plant after 5 days. So let's look at some classes. We might have 0 to 5, then 6 to 8, let's say 9 to 11, and then let's say 12 to 14. Let's first consider what we call the class boundaries. This one will go up to 5.5. It will exclude the value of 5.5 and be a strict inequality. If you like, what we can say is that the height is going to be now greater or equal to 0, yet in turn less than 5.5. If we look at this one, this is going to go from 5.5 to 8.5. 8.5 will be excluded. 8.5 to 11.5. 11.5 excluded. 11.5 to 14.5. What we're going to do is start by finding an estimated mean for this data. So what we first need is a frequency. So let's write on some frequencies. Let's say we've got, let's go for 2. Let's say we've got 2. Let's say we've got 8. Let's go for 8 in that one. Let's say we've got 9. And then let's say we've got 7. So this is our frequency. What we need to do to find an estimate for the mean from continuous group data, we say x bar, which is the mean, is going to be now the sum of fx divided by the sum of f. X is the midpoint of each of these classes. Now if we look at the midpoint of this one, we can see that x, or the midpoint, is going to be 2.5. So in this one we're going to put 2.5. Now technically this is going from 5.5 to 8.5, but essentially the middle is still going to be 7. We're going to have 10, and then in the last one we're going to have 13. So what we now need to do is multiply these two. So what I'm going to have is fx, and this is my column right here. So if I multiply these two, that's going to give me 5, that will give me 56, that will give me now 90, and that will give me 91. So let's look at some totals. So what we've got then down here, let's write on the totals. We've got now the sum of f. So what I'm going to do is sum this up. So we can say now the sum of f will be equal to, this is just the sum of the frequency, that's going to give me now 26 in total. So all I've done is added that column. If we now look at the sum of fx, we're going to have now all of these numbers added up. So let's go ahead and add those up. So if you want to do it in your head, you can do. If you want to do it on a calculator and be slightly lazy, you can do 5 plus 56 plus 90 plus now 91. We will get that value. That's going to be 242. So 242. So all we need for an estimate for the mean, and this is an estimate as these values could lie anywhere in between these. So if we know that this is going from 5.5 to 8.5, all of these might be bang on 5.5. Or they might be right at the other end, just slightly less than 8.5. And that's why it's an estimate. So what we can say then is an estimate for the mean, x bar, is going to be now this right here, which is going to be 242 over now the 26. So let's put that through a calculator, let's divide that, and that's going to give me now, what's that, 121 over 13, 9.3, and we'll say that that's going to be 9.31. I'll do that now to 2 decimal places or 3 significant figures. So let's write that there, 9.31. So we can say that x bar is going to be equal to 9.31 centimetres, millimetres, working in millimetres, aren't we? My apologies, let's switch it over, millimetres, and that is going to be to 3 significant figures. You'll be given a level of accuracy in the exam, so 3 SF. So all we've done here is found now the sum of the frequency, we've looked at the midpoint of each class, and we've gone ahead and simply multiplied the two and ended up now with the sum of the frequency times the midpoint. We've got the sum of the frequency, we divide the two, and this will now give us an estimated mean. Now let's look at that. Is that a realistic value? Well, it looks fairly realistic. At least it's not now a negative number or beyond 14. So an estimated mean 9.31, correct to 3 significant figures. Okay, what we're now going to do is look at finding an estimated median. So what we want to do is locate a middle value. In all of these problems, when we're looking at the mean and the median, we're looking at now a focal point, a central point. So we're looking at measures of location. Now, the way in which we do this is consider the cumulative frequency. So the columns that I'm interested in now is this one, the height. I want the height, and also I want the frequency, and I'm now going to write cumulative frequency. So in this column, I'm going to look at the cumulative frequency. So I've got now 2, I've got 10. That's just 2 plus the 8. Plus the 9, which is going to be 19, plus now the 7, which is 26. And that stacks up right here. So this is the cumulative frequency column, and then of course we've got the frequency. So what we're looking for is an estimated median value. Now we use something called interpolation to find this. So what we're going to do is consider now our total number of observed values, or now our frequency. Our frequency is going to be 26. So frequency is 26. For the median, we need to divide this by 2. As it's group data, we don't make any alterations, as this is simply now an estimate. So what we can say then is our median value will happen on the 13th observation. Right, all we have to do with this now is set up a little diagram. You certainly don't have to do this, but it might help you out. So what I'm going to have now are these 2 endpoints. If we look at this column now at cumulative frequency, we can see now that the 13th observation will lie in the class now 9 to 11. So at this point we've already seen 10, so we need to go into this one now to see the 13th. All we're going to do is set this up now down below. So let's consider what we've got. We're in this particular class right here. I'm going to take now the class boundaries. That's going to be 8.5. Then we're going to have now 11.5. That's the class boundary. If I now look below, we've got 10, which is going to be the cumulative frequency at the start, and 19 at the end. Now, we know that this median value will be taken from the 13th one, so we can put now that this is going to be 13, and then above it we're going to have m. The way in which we look at this now is an equivalent fraction. I actually prefer to look at it as similar triangles. It's nothing really to do with similar triangles, but it might help your understanding. And I'll show you what I mean here. If we had now similar triangles, let's just do this. Let's go ahead and say that these were similar. If we had now 10 and we had, let's say we've got 8 just here, and we've got 5 and we've got x. What we could say here is x over 5 will be equal now to the 8 over 10. Now from this you can see essentially all we're going to do is multiply both sides by the 5. That will give us now 40 over 10, and x is going to be 4. That's pretty much what we're doing here. What we do is the following. We say now that m, the median value, minus 8.5 over now the 11.5 minus the 8.5, 11.5 minus the 8.5 will be an equivalent fraction to 13 minus 10 over now 19 minus 10. So all we're doing is simply looking now, and you can see that these are equivalent fractions in the same way this is. This has no real bearing, but it might help you in terms of just getting your head around this. Okay, so what we've got then, this is going to give me 3. So we can say m minus 8.5, and I'm going to multiply both sides now by 3. This fraction right here, that's going to give me now 3, and that's going to give me 9. So this is going to give me 3 over 9, which is going to be 1 over 3. So from here we can see that's going to be 1. So we can say m is going to be equal to, adding the 8.5 to both sides, 8.5 plus 1. This is working out quite nice, and the median value now is going to be 9.5. So that's an estimated median. And again, let's have a look at that. Does that seem logical? Well, it should do, as now our 13th observation is going to be somewhere past the 9. Remember, this is an estimate. It's somewhere in this particular class. And again, we're just looking at that estimate. So that just gives you some idea on how you can do it. It's this one, subtract now. So the median value, subtract the lower boundary, so this is the lower boundary of the class, now over the 11.5 minus the 8.5, then we set that to equal to 13 minus 10 over 19 minus 10. This gives me 3. This gives me now 3 over 9, which is 1/3. Multiplying both sides by the 3, and then we simply do that. So the median estimated value is 9.5, and this is an estimate. So that's how we find the median. We use interpolation. So with your group data, we're not going to, so for example, if we were looking to split this, we wouldn't do anything more, as it's just a case of taking n and dividing it by 2. When we look at the lower quartile, it will be n divided by 4, and then when we look at the upper quartile, it will now be 3/4 of n. Again, we don't need to make any rounding, or we don't need to round up just because now we need an integer value. Okay, let's have a go at another one. Let's pick another table. So let's say this time we went for the lengths of something. Let's say these were the lengths of leaves. So let's get some leaves up. And what we'll have is the length, and let's do the length in centimetres. So this now is the length of the leaves in centimetres of some plants I have. So let's have some classes again, 1 to 3. Let's go 4 to 6. So 4 to 6, let's go 7. Let's do 7 to 9. What else? Let's go 10 to 13. I think we'll do one more as well. Let's go 14 to 16. So let's just consider what these are. If we look at this one, we've got now 13.5 to 16.5. We've got 9.5 to 13.5, and so on and so forth. So let's look at a frequency. Let's just do some values of the frequency. Let's say we got 4, let's say we got 5, let's say we got 3, let's say we got 6, and let's say we got 7. So what we're going to do is go ahead now and give this, let's start with an estimated median. So what we want to do is find now x bar. So x bar is going to be the sum of fx divided now by the sum of f. So what we want now is x. X is the midpoint of each of these. So let's put x on here. So that's going to be now 2. Then the next one we're going to have 5. Then we're going to have 8. We'll have 11.5, and then finally we'll have 15. So let's have now an fx column. This is the frequency times the midpoint. So frequency times the midpoint, we've got now frequency times the midpoint, that's going to be 8, 25, 24, then we're going to get on this one, what's that going to give me? 69, and then we're going to have 105. Okay, so let's look at our totals again. So writing down in the bottom, totals. So the total now, we've got the sum of f. So let's go ahead and add these up. That looks to be, what have we got? 25, okay? So let's add that one up. And now we need to add this one up. So let's put that through a calculator. I'm going to need it later anyway. 8 plus 25 plus 24 plus 69 plus 105. So that sum gives me 231. So we can say the sum of fx is equal to 231. So if we want x bar, which is going to be now the mean, all we're going to do is divide the two. So x bar will be now the 231. So 231 over now the 25. So let's go ahead and do that, dividing this now by 25. That's going to give me 9.24. So we can say x bar, so that's an estimate for the median, for the mean, 9.24, and that's centimetres. Now just think about this, does that seem logical? 9.24, it's somewhere in the middle. We've not ended up with something ridiculous, so that looks pretty good. Okay, what we're now going to do is consider the quartiles. Now Q1, let's just write these down. Q1 is now seen to be the lower quartile. So if you hear Q1, it's lower quartile. Q2 is the median. And we've already seen the median before. Q3 is going to be the upper quartile. So 25% of our observations lie below the lower quartile, 50 now lie in what we call the interquartile range. So we've got the interquartile range here, and now 50% of observed values fall below the median, 75% of values fall below the upper quartile, or Q3. We're going to go through this and work out estimates for each of these quartiles. Now, if we consider we've got 25 data items. So we're going to take this now, just consider this, all we're doing is finding a quarter. So this will be taken on now the 25th over 4. So that's going to be equal now to 6.25, and we don't need to round it. The median now is going to be 25 over 2, which is going to be 12.5, and then finally we're going to have 3 quarters. So what we want then is the 3 quarters of 25, which is going to be 18.75. Let's write that down. 3 quarters of 25 is just going to be 3 lots of that, which is going to be 18.75. So let's go ahead and find an estimate for each of these. So what we're going to do is the following. Let's just draw these lines. You certainly don't need to draw the lines, but it might help you out. So on the first one, what we're going to have now is 6.25. So if we look at 6.25 now, we need to know where this falls. So I need a cumulative frequency column. So if we put the cumulative frequency column up, we've got now cumulative frequency. So cumulative frequency, we're going to have 4, we're going to have 9, we're going to have 12, we're going to have 18, and we're going to have 25. Again, check these two values work. So I'm going to set this up. Now, if we look at the 6.25th term, that's going to fall into this class right here. So the 6.25th one will be in here. So we can see we got 3.5 and 6.5. So let's go ahead and put these on. So we'll have 3.5, and then we're going to have now on the other end 6.5. Down the bottom, we're going to consider now the cumulative frequency. I'm going to have 4 and I'm going to have 9. So 4 and 9 are going to be here. Now, the value that we're after is the 6.25th value, and we're going to call that Q1. So going back to interpolation, what we can say from here now is Q1 minus 3.5 over now 6.5 minus 3.5. 6.5 minus 3.5 will be the same now as 6.25, and that's going to be minus 4 over now 9 minus 4. So let's do a bit of tidying up. We've got Q1 minus 3.5. This is going to give me 3, so I'm going to have 3 multiplied now by 2.25, so 2.25 over 5. So let's now go ahead and just add the 3.5 to both sides. Q1, this is an estimate for the lower quartile, will be 3.5 plus 3 lots of 2.25 divided by 5. Straight for a calculator with that, so let's do that. So we got now 3.5, and then we're going to have plus 3 lots now of the 2.25, and we're going to divide this by 5. So we want an estimate for that lower quartile, which is going to be 97 over 20, 4.85. So Q1 will be 4.85. And I defined these earlier to be centimetres. So it's going to be 4.85 centimetres. So that's sorted. So that is done. Let's now go ahead and look at Q2. Q2 is going to be the median. If you like, you can use median or you can use Q2. So this time we've got now the observation we're interested in is the 12.5th one. So if we look now at our cumulative frequency, we're up to 12 just here, so I need to go into this class right here. Often students stay in this one because they see 12 there and go in here. In the same way they might have gone in the other one. We need to consider this class right here. So what we're going to have then is the following, 9.5 and 13.5. So let's go ahead and do this, and let's just do this one here. We're now going to look at the median. So we've got now 9.5 here, so 9.5. Then at the other end, we're going to have 13.5. If we consider the cumulative frequency, we've got 12 and 18. So let's put 12 just here. So that's 12, and this is going to be 18. We're looking at now at the 12.5th term, which is going to be about there. Again, this doesn't have to be massively accurate. And I'm going to say that this is going to be the median, if you like, Q2. So M is going to be just here. So what we can say then is the following. M minus 9.5 over 13.5 minus 9.5 will be the same as 12.5 minus 12 over 18 minus 12. So what have we got here? We've got now m minus 9.5. That's going to give me 4. So we can write this as 4 lots now of 0.5, so that's going to be 0.5, over now, that's going to give me 6. So what have we got in total? Well, that's going to give me 2 over 6, which is going to be 1/3. So we can say m will be equal to 9.5 plus 1/3. If we just look at this, 4 times by half is 2, 2 over 6 is 1/3. So let's do now 1/3. So let's have our 1/3, and then we're going to add to that now. So we're going to add now the 9.5. So that's going to give us our value, and that's going to give us 59 over 6, which is 9.83. So m is equal to 9.83, and that's going to be centimetres, and that now is to 3 significant figures. So that's an estimate for the median. And if we look at that now, it's just dipping into this one right here. So that's a fair assessment to make, about 9.83 centimetres, given now that it's just inside this particular class. Okay, let's now look at the upper quartile, or Q3. And the reason I've put this one over here is I like to put these below each other. So what we're interested now in Q3 is the 18.7 fifth term. So if we think about the 18.7 fifth term, that's going to be in this one right here. So what we're going to have then for the class boundaries is 13.5 and 16.5. So let's go ahead and do that. So let's put these on. We're going to have now 13, let's just check I've got those right, 13.5 and 16.5. So we'll have that, and let's put that here, 13.5, and then we're going to have 16.5. So these are the class boundaries. If we consider now, we're going to have the cumulative frequency at this point is going to be 18, and this one is going to be 25. So what we've got then is 18 just here, and then we've got 25. So this 18.75 is going to be just like so. And what we're going to do is put on here that this is going to be Q3, or now the upper quartile. So working this out, let's write this below. We've got now Q3 minus 13.5 over 16.5 minus 13.5 will be equal to 18.75 minus 18 over now 25 minus 18. So that's going to give me 3. So we can say Q3 minus 13.5 will be equal to 3 lots of 0.75 over now 7. So Q3 will be equal to 13.5 plus now 3 lots of 0.75 over 7. So again, into the calculator with that, we've got 13.5 plus now, I don't want that one, plus 3 lots now of 0.75, and we're going to divide this by 7. Okay, let's go ahead and do that. And that's going to give me now 387 over 28. So what's that going to be? 13.8. And we'll say 13.8. And again, that's the 3 significant figures. Or if you want to round like we did essentially on this one to 2 decimal places, we could round to 2 decimal places. Let's say 13.82, and that'll be centimetres. And that's the 2 dp. I appreciate on the last one, I'm not being consistent as such by rounding, and I will leave that to you to decide. The question will tell you which to go through. So that's Q3. So that now is going to be the upper quartile. So if you wanted to display this as a box plot, what you would have now, let's just look at the middle section of this, we could put on these values. So let's just draw up a box plot, not massively accurate, but it'll give you some idea in terms of the estimated values. So we got 4.85 for Q1, 13.82 and 9.83. So let's just go ahead and scribble those on. So that now is going to be 4.85. So 4.85, we've got the 13.82, and then we'll put now the median in the middle. Well, not in the middle of these two as such, but it will just be somewhere around there. Okay, and that's going to give us our 9.83. So 9.83 0.83. So these are our values. This is now the lower quartile, an estimate for it. This is the upper quartile, and this is a median. So we might be asked to find an estimate for the interquartile range. So all we need to do is take Q3, so we can say that the IQR is going to be equal to the upper quartile minus the lower quartile, or if you like, Q3 minus Q1. So what's that going to give me? It's going to give me 13.82 minus 4.85. Let's do that. So minus the 4.85, and that's going to give us a value now of 8.97. So we can say IQR, let's write this in, IQR, I've either got IIQ, IQR, that makes no sense, does it? Never mind, let's write it in. IQR, so IQR is going to be equal to the value on the calculator, which is 8.97. So 8.97, and that's going to be centimetres. So there we go, that's using interpolation now to find the median and the quartiles of group data. So this is continuous group data, and again, we don't know where these lie within these classes, therefore it's just an estimate. So there's a brief intro. In later videos we will look at some other examples of finding medians and quartiles, and also look at some coding. But for now, hopefully that's given you a starting point.